What I want to do today is give you a little bit of an overview how NASA has been involved in the National Climate Assessment through both the lens of decision support and climate literacy. So as a first step, I'd just like to remind you, NASA indeed does Earth science. For over 40 years, we've used the vantage point of space to study the Earth as a system and to look at land and oceanic and atmospheric processes and their interactions. We currently have 18 operating Earth science missions that we work with interagency and international partners to operate, and these collect a whole host of observations that are relevant to the National Climate Assessment. The satellite data allow us to understand land use and land cover change, temperature, precipitation, ocean salinity, winds, and a whole host of other things related to water resources and a variety of other science applications that really are critical, that were really critical to understanding the National Climate Assessment. So NASA is a key member of the U.S. Global Change Research Program, and as such, we were active participants in the National Climate Assessment. NASA Science and Applications actually underpinned a lot of the climate assessment report, most notably the climate science chapter, but it also permeated many of the other regional and sectoral chapters. For example, a satellite-based estimate of forest disturbance was used in the forestry chapter, and NASA satellite observations and models were used to understand changes in soil moisture over the past decade. And so our general strategy to support the National Climate Assessment, and also most critically the sustained assessment process, and that's something that we as an agency are really interested in, is doing really good science and really good applications, making that available and accessible so that the climate assessment, people working on the climate assessment, but also end users in communities can actually use this information, making sure that we understand the community needs, and that means both the science research community needs as well as the end user community needs, and then making sure that we get out that message. And the work's not done until we actually are able to tell people what it is we've done and why and how it impacts them. And we do that generally speaking through the public and also through educational activities. I realized from the last talk that I probably confounded literacy and education and outreach and communications, but I hope you'll forgive me from the science side for that. So why does NASA participate in the climate assessment? We want to ensure that NASA data and models and researchers are available to the climate assessment so that the climate assessment can draw on NASA capabilities. And we have a couple of objectives for our participation in the assessment. The first is to do assessment relevant science and develop these research products. And so the programs that we've implemented have put some of this assessment overlay into our otherwise wide array of research and applications activities. And so by helping our community do assessment relevant science, they're able to do work at spatial scales that tend to be a little bit smaller, both the spatial extent and the grain of extent, so at a finer scale of analysis than we typically do at NASA, and this is something that tends to be more useful for decision makers. And the second thing that we wanted to do was invest in the community of researchers so that they understand what it is to participate in assessment, so that they can better participate in assessments. Because the assessment, as we've mentioned before, it doesn't just get magically written. A lot of people are involved, and so if we have people that are better understanding what is an assessment, so that can inform their research and applications activities, and so that we can train graduate students and postdocs and early career scientists to participate in assessment activities, we can do better assessments both at a national scale, but also at a regional scale and local scales. And so that's what our goal was, is to foster our community to better understand how do you participate in an assessment. And so what we've been doing is supporting this through a variety of research programs, because as a research and development agency, a lot of what we do is fund research, and this is sort of our climate assessment overlay to a variety of our research programs. So the first is we did back in 2011, so when the third climate assessment report was just getting underway. We issued a call to our NASA research centers, and we funded 14 projects to do assessment relevant science and to develop enabling tools. I'll talk about the enabling tools in just a moment. But the assessment capabilities projects looks at things like, for example, that figure on the upper right that is looking at climate controls on fire frequency so that we understand how fire frequency has changed in a changing climate and how fire frequency might change in the future. We also funded several studies that looked at public health and the effect of heat waves on public health. And then we also actually, it was a really interesting study looking at the building zones for the climate zones for buildings and how you would change building design standards under a changing climate. And so these are the kinds of projects that we helped foster. And those projects lasted for a period of 3 years. We had another solicitation that was open to the entire research community that focused on developing potentially new indicators of climate change using remote sensing resources. And so this was sort of to kind of encourage and spur new thinking in the indicators arena. Those projects are also coming to completion. We coincidentally funded 14 as well. And all of those projects' abstracts and further information is available on our NASA National Climate Assessment website. And finally, we have a new solicitation that's open to the research community that's on the streets now. Proposals are due February 2nd if you're interested. And that's picking up on both the climate indicators and the data products for the next climate assessment. So these enabling tool projects I want to go into a little bit further because these are projects that we've continued for another 3 years. So they started in 2011 and they'll go through 2017. And these pick up on major research endeavors and modeling endeavors at our NASA research centers and helps them do that work with a little bit of extra climate assessment focused. And so there's 4 projects in total. And again, all of these projects have talks here. So if you're interested in any one specifically, you can search the AGU agenda to find more information. And just as a plug, I forgot to mention on the last slide, there's actually a climate indicator session, both a poster session and an oral session if you're still here on Friday. We'd love to have you come and you can hear more about the climate indicators projects and a variety of other climate indicators activities there. So the first set of projects that I wanted to talk to you about are both based at our Goddard Space Flight Center, and they focus on reanalysis tools for the satellite era, which is 1979 to the present. And so reanalysis uses models and a process called data assimilation to analyze many observations, both in situ and remotely sensed, into creating these consistent global realizations of weather and climate. So I realize that's a lot of potentially a lot of modeling jargon in there. But the idea is basically creating these spatially consistent data sets. So it's not just an observationally based data set. They combine that with models to create an understanding of what have trends been in the past 35 years. And so one of these projects is focused on a reanalysis called MERA, and it's focused on more atmospheric and climate conditions, and they're looking at connecting large-scale weather events with historical extreme events to be able to better forecast and prepare for future extremes. And so this is actually, it was a study that looked at the association between extreme precipitation in the Northeast and what those extreme precipitation events were associated with lower sea level pressure off the East Coast. And so this is just the kind of scientific information and understanding that you can glean from these reanalysis projects. A second project was focused on the land data assimilation system and developing a terrestrial water analysis for the climate assessment. So it's also a reanalysis project, but it focuses a little bit more on hydrological conditions. And this is an example of looking at runoff trends from 1979 to 2012. And you can see that there's been an increase in runoff in the Northeast, and that's one of the key findings of I believe of the Northeast chapter was increased precipitation events and extreme precipitation events, and also drying in the Southwest. And both of these projects have been working and are developing new iterations of visualization tools so that researchers and others can come in and actually take a look at this data and build some of these maps for specific variables that they're interested in. A third project is looking at how to better evaluate regional climate models. So regional climate models are really important because they occur at a finer spatial scale than these global climate models, which helps decision makers better plan for adaptation and mitigation activities related to climate change. Evaluating these models is really helpful because it can help us build better climate models, and doing so requires both in situ and satellite observations. Doing this is really hard and quite the technological challenge. And so this project helps bring in a relatively easy to use format, in situ observations and remotely sensed observations into a database and a toolkit to better be able to evaluate these regional climate models. And then a fourth project is the NASA Earth Exchange based just down the peninsula at NASA Ames. And this is also a project that helps get over a lot of the IT challenges and also a lot of the computational challenges. So a lot of research projects, you have to download a lot of data, you have to do these huge computational analyses. And when we're talking about satellite data, there's a lot of data. These are really big data sets. And so what NEXT does is provide a way to bring in these satellite data sets and these computational capabilities to do some amazing research analyses that would be very difficult to do just by a single researcher and just sort of with a single or several computers. And so one of the products that they've produced is a downscaled high-resolution data set for the United States looking at various climate projections at an 800-meter resolution and focusing on temperature and precipitation variables. And this data set was featured in EOS last year, and USGS has picked it up to provide some specific tools that makes it more easily accessible. So it's a kind of example of one federal agency is picking up on another federal agency's work and really helping create some value-added work to that. But this downscale climate data is valuable not just so we can say temperature will be X or precipitation will be Y in a specific location, but we can actually then use NEXT to look at the ecosystem models that are within there, input this temperature and precipitation and a whole host of other information in there as well, to look at changes, for example, in gross primary productivity under a high emission scenario and seeing how gross primary productivity is expected to change under a changing climate and whether in places where it's expected to increase and decrease and can do those further investigations. And so all of these data are available through NEXT and a variety of other sources. And also there's some ways to capitalize on these computing resources. And so there's two avenues to do this. One is a partnership called OpenNext with Amazon Web Services, where anyone can come in and use some of this data and do some additional analyses of their own. There's also ways to apply for NASA funding to do specific research with these projects. There's also, the NEXT has a great website. They have a lot of workshops and lectures and labs, and so there's a lot of information out there at a variety of different levels. And for example, they just hosted this past Saturday at AGU a Climate Change in My City hackathon, where they use this downscale climate data set to help people, to encourage people to create tools that will help people understand how climate is changing in their cities. So the work's not done, though, till we get our message out. And so we, NASA partnered with the National Climate Assessment to support a variety of outreach activities related to the third climate assessment report that also capitalize on a lot of our NASA communications and education's work. So the first is that we helped fund several town hall workshops that helped provide to the public information about the draft third national climate assessment so that they could provide feedback in a variety of ways. And this is actually Steve Running, who was an author on the forestry chapter, is also a NASA researcher, and is also the chair of our NASA Earth Science Subcommittee, talking about that forest disturbance map that he actually, I'm not sure if he was actually part of that research, but he was presenting that research in the public town hall. We also helped develop a workshop on building capacity and engagement around the third climate assessment report. So several months before the report was released, we brought together, and Emily did a lot of work to make this happen and really led the efforts here, to bring together federal agencies, local governments, NGOs, and a variety of others to talk about how they can better do outreach regarding the third national climate assessment report. And we at NASA helped provide some information about our educational resources. A lot of other federal agencies provided some great resources as well. And so this was, I think, a really good way to help get the message out about the climate assessment report. Something that's really fun that we did was enlist the support of our scientific visualization studio. So in cooperation with the NOAA National Climatic Data Center, who produced some of the downscaled climate data that was used for the third climate assessment report, so those temperature and precipitation, how to expect temperature and precipitation to change, we had them work with our visualization studio and develop these animations showing how temperature and precipitation will change. And so just for your reference, so this is looking at precipitation, and bluer means areas that have a higher percentage change, more water, basically more precipitation, and the browner areas are areas that have less precipitation. The B1 scenario is a lower emissions carbon dioxide scenario, and the A2 is a higher emissions carbon dioxide scenario. And if we click on this, somehow, no, there we go. So I'll let you watch that again. And we released this on our visualization website. We also had an iPad app. We did working with the climate assessment, we did a press release around it. And this received a lot of public attention and really helped draw people in a way that I think that still images alone, did to some degree, but this was sort of an additional avenue. And so this has been a really great resource for the climate assessment, and if you'd like to see these, you can just Google SVS NCA, and they should probably pop up, and if not, my email's at the end. Feel free to email me. And we also used our social media. We have, I think, 9 million likes on Facebook. So, when the climate assessment came out, we helped support the messages. For example, we developed these shareables, which are basically bits of information that draw people in. And so I think we did 6 or 7 of these for the climate assessment release. And this one is focused on understanding how much, so it draws you in with a picture and a question, how much warmer will your future be? And then there's a short message at the bottom, which might be a little hard to see, but basically it says, temperatures are expected to change 5 to 10 degrees Fahrenheit under a business as usual emission scenario. And then when you click on it, you get a lot more information about what the visualization is, what it shows, and and then connects you to information from the climate assessment report, and then also links you to additional resources about what NASA is doing in the future. So for example, it linked to our Orbital Carbon Observatory 2 mission, which was launched just this past July, that's measuring atmospheric carbon dioxide. And so it helps draw people in and say, this is what's happening, this is how it's affecting you, here's more information, and here's some information for the future. Something else that Fred mentioned in his opening talk was the Global Change Information System. And the idea behind this is to use is to help make the information in the report more accessible to researchers, to the public, for people for education, or someone who's just curious. And can really help people feel more confident about the report findings if they can understand why that report finding was made. And so NASA lent the support of 2 detailees because we have a lot of expert in data provenance. And so by lending that support to the climate assessment, this is actually a U.S. Global Change Research Program more broadly, we were able to bring that expertise. And so, for example, when you click on a figure, you can get more information about that figure. You can find the paper, the scientific paper behind that figure. You can get the data set that supported the paper. And then you can even get information about the instrument that was used to make these measurements that that supported the data product, that supported the paper, that supported the figure, that supported the finding in the assessment. So you can trace it all back, and that's why they're called traceable accounts. And I think that this is a really strong way to sort of encourage people's curiosity from a very lay perspective, but also if a researcher came in and said, I want to know more about this, they could actually get really solid scientific information and really understand why a decision was made and what's the information behind a figure. And finally, I'm not going to dwell on this point too much, since we just had an excellent talk about the education resources, but a variety of these resources were created for regional and sectoral areas, and NASA Langley was involved in developing the one for the Southeast region and the Caribbean region. But what they've additionally done is our STEAM program is holding a variety of online webinars, and they do a whole lot of work related to climate and energy work with K through 12 educators, and I think even minority universities as well. And we're having these webinars that helps teachers understand how to better incorporate this information. They've had a lot of participants in these webinars. That's an example of one of the webinars below. And if you're interested, their next session is actually on January 15th at 4:30 Eastern, and you can find more information on their website, esteem.lark.nasa.gov. Again, my information is on the next slide, so feel free to contact me if you have any specific questions. So with that, I hope I've given you a sense of how NASA has helped contribute to decision support and greater public knowledge about the climate assessment. Thank you.